We'll now see an overview of the RStudio workspace and go through some basic R programming review. If you have quite a bit of experience in R programming, then this will be very simple for you. If you're new to R, it'll give you a quick overview of some of the basics in terms of reading data and managing data, working with simple data sets, and then there will be a lab to follow as well. So first, let's orient ourselves to the RStudio window. There are different ways that this can be configured, but we'll try to have this layout the same throughout the course. There are really four panes that you'll be interested in viewing. The first is the editor window, and that's where we're at now, the editor. This is where you write your programs, or scripts as we call them in R. So this is your main programming window. Then we also have the console, which can be found underneath the editor or the programming window. Your console is down here. What will happen is whenever you execute R scripts or any part of the R code, it'll show up here, and most of the time you'll have some output here. There are some whenever you don't, but we'll kind of deal with those as we come across them. But for the most part, you get some output here whenever you're running code. This will also be the place where you see error messages pop up, and things of that sort. Typical things that you would look for whenever you're running a program. So the console shows the commands you are writing, or what code you've executed, and you can also write directly to the console. So I could write an R command down here and it would execute just like if I did it in the editor window. Then we have the environment pane, which really just shows all of the objects in your current R session. So if you have various data sets open or files running or variables stored, anything like that, it'll show up here over in the environment window, which is now empty because we haven't executed anything in this R session. But as we do, you'll see that populate. And then the fourth pane is the plots, packages, and help, which are tabs with additional info about your session. So down here in plots, when we create a plot at the end of this video, it'll show up here. Packages shows you where you can install or update. It also shows you what packages you currently have loaded. And then the help, you can use the built-in search functionality to find really any R documentation you would need for various packages or functions, things of that nature you can use in the help window. So that's handy to have right there for you. So that's a quick orientation to the four panes in your R session window. We have the main editor where our programming will take place. We have the console where the commands are printed out and the output is placed and any error messages will show up. The environment pane, which shows us all of the objects that currently exist. And then plots, packages, and help down here just for additional information. So let's start doing some basic programming in R, and we'll kind of look at how the four panes populate as we go. So the very first basic command you need to know in R is the assignment operator. So let's create a data frame called data.00, and the left pointing arrow is the assignment arrow. It means whatever we type next is going to get assigned to the object called data.00, and we'll use a built-in data set called mtcars. Now I executed this line of code, so let's look at what happened. The first thing that happened is everything we ran showed up in the console. We have our header, which are commented out with the hashtags, and then we have the line we just executed, data.00 is mtcars. Over here in the environment window, we see that we now have something in our R session called data.00. There's a very handy functionality here where we can click on this and it'll open up our data set. Now, two things happen here. One, the data set, data.00, opens up in the data viewer over here by the editor tab, or in the editor pane. Also, you'll notice there was an additional command written down here in the console, view data.00. So by clicking on the name of something here, you execute a view command. Now, this is there's sort of an underlying philosophy when you're working in R. There are really two statements you need to remember. First of all, everything that exists is an object. So if you have a variable or a data frame or a matrix or a tibble or anything like that in R, it will exist over here in the environment window. Anything that exists is an object in your R session. The other statement to remember is that anything that happens is a function call. So even by clicking on data.00 over here, we call this function that we can see in the console view. So in R, just remember, everything that exists is an object, everything that happens is a function call. Now in our fourth pane, I'll just point out there's nothing that's happened here yet because we haven't done any plotting, we haven't needed a package, and we haven't searched for anything in the help. So there's nothing to be populated here. Let's go back to our editing window. We now have some data called data.00, and we use the assignment operator to do that. So the left arrow is the assignment operator. It's how you create something new. Now let's move into the next section where we'll look at viewing specific rows, columns, entries, etc. using the $ and the IJ notation. So we'll first look at the $. If we check out our data set real quick, we see that we have some cars data. And so over here the row names are various makes and models of cars. And then we have things like their miles per gallon, the number of cylinders, displacement, etc. We have several variables pertaining to these types of cars. Now each of these variables has a name: MPG, CYL, DISP, HP, DRAT, etc. We can view just one of these using the $ operator. You'll see that RStudio automatically populates the list of variables. That's because the $ operator on the end of a data frame means we're about to call one of these variables. So we can pick whichever one we want to see. Maybe we'll just see MPG. When we execute that, you see in the console we get the line we executed as well as the output. So the output here is the vector, or is the list, we'll say for now, of the values that are in the MPG column of data.00. Let's go back and look at our data frame. MPG is 21, 21, 22.8, 21.4, 18.7, 18.1, and so on. And we can see that these are the exact values that have been populated in the console. It really just prints this list of values. That's the $ operator. We could do the same thing using this notation. MPG. Okay. So by using MPG, we get exactly the same thing. Now, what's happening in that square bracket structure is we're actually telling RStudio which rows and columns we want. So the first argument here is going to be rows, and the second argument is the columns. So what we did here was actually tell RStudio we want all of the rows by leaving it blank, and we want only the MPG column. We can do that same thing here, but we can actually do it numerically if we notice that the MPG is actually the first column in the data set. So we'll go ahead and execute this, and you see in the console we get exactly the same output. MPG in our data is the first column, and so we tell R we want to view the first column, and we viewed all of the rows. Now we could actually subset this to specific rows by filling in. Maybe we only want the first 5 rows. So using the exact same syntax, we say we want to see data.00, but we only want rows 1 through 5, and we want column 1, which is just MPG. And in the console we'll get that, only the first 5 values. And actually, if we wanted to see all of the first 5 observations, we could say we want to see rows 1 through 5, and we'll leave the columns argument blank to say we want all of the columns. And when we print that in the console, you see that we get not only the first 5 values of MPG, but also the first 5 values of everything. We get all 5 observations in the data frame. So that's just kind of a quick overview of how to view some subsets of the data. There are also a couple of other built-in functions you can use, like head.data00, which shows you the first 5 or 6 observations of the data. We can do tail.data00, which will always show you the last 6 observations. And then another handy function is the structure function, or the str function, which doesn't mean string, it means structure. And that will tell us in the console what's in our data frame. So we can see here in the console, structure of data.00 is it's a data frame. It has 32 observations of 11 variables. We have then MPG as a numeric variable, cylinder is a numeric variable, displacement is numeric, and so on down the line. We have 11 variables. They happen to all be numeric here. But if we had things like factors or characters or anything like that, they would show up there as well. So some handy functions just to get oriented to your data. Now let's talk about the TidyVerse. I'm going to load a package, and if you haven't already installed the package in your R session, you'll need to do that. But let's load the TidyVerse package. Give that a second to load. Now the TidyVerse package is an all-around functionality for data wrangling. There are a few things you want to remember whenever you're working under the TidyVerse framework. The first is that every column is a unique variable. Every column in your data frame is a unique variable. The second standard is that every row is a unique observation. In other words, every row in your data frame should have one unique key and one unique purpose. The third standard is that as you're processing data, only keep what you need in a data set. So we don't want to carry a lot of extra variables or a lot of extra observations as we're processing. That helps keep our programming clean and efficient and makes us less prone to mistakes if we're constantly thinking about what do we need. So every column will be a unique variable, every row will be a unique observation, and we'll only keep what we need in each data set. So if we look at our data.00, we can see that it is relatively tidy data. Every column is a unique variable. None of these repeat or overlap one another. Every row is a distinct or unique observation. In this case, it's a different make and model of car. And there's no erroneous data here. This is a car data set, so it's not like we have a variable that tells us what the weather is on a given day or anything that would be irrelevant to the data set. So this is a fairly tidy data set, and we want to keep all of our data this way no matter what we're doing. That framework will also come in very, very handy if we think along those lines once we get to our machine learning algorithms later in the course. Particularly every column being a variable or a feature, and every row being a unique observation or a unique case. We'll use that structure a lot in our machine learning algorithms. Let's talk about managing data now, data frames, under the TidyVerse framework. So the first thing is, how do I work with what I have in a data set? So one thing you might do a lot is filter your data. Filter is a row subsetting function. So let's filter data.00 to only cases when cylinder is equal to 4. Now if we go back and look at our data real quick, cylinder has a number of values, 6, 4, 8, and those are typical values for cars. They tend to have either 4, 6, or 8 cylinders. So this is a row subsetting function again that will filter our data to only cases that have 4 cylinders, as we can see in the console. So filter again is a row subsetting function. Another thing we could do is maybe select. Now select is our column subsetting function. So maybe we want to select out of data.00, we only want MPG and cylinder. And now we can see here in the console that when we run this, we get our same data frame, but we only have the MPG and the cylinder functions. So those are probably the first two functions you'd want to use. And this is a column or a variable subsetting function. Filter and select help you cut into your data set so that we're only keeping what we need as we're processing the data. Now, let me also show you the piping operator. So here you can see in both filter and select, we've included data.00 as an argument to our function. We're telling filter, for example, that we want to filter the data set data.00. Well, when we string functions together, that can become complicated because we have to always tell the function what data it should be reading. Well, an easy way to do this in the TidyVerse is what's called the piping operator. So we'll take data.00, and the pipe is percent greater than percent. It's called a piping operator. And what that does is it tells R that we're going to take data.00 and we're going to pipe it into another function. So in this case, we could pipe it into the filter function. And now we give our condition when cylinder equals 4. We'll go ahead and execute that, and you see in the console that we get the same output as with our filter call directly reading in data.00. The piping operator again says take data.00 and pipe it into filter as the data to be filtered, then with our condition. Now we can do the same thing with the select function. Take data.00, we'll pipe it into the select function. We'll select MPG and SIL. All right, and now we'll go ahead and run this. And we can see that again we get the same output we expected. MPG and SIL are the only two variables remaining. Now actually, just for fun, we could do a double pipe here. You can string these together as far as you want. So maybe we select MPG and SIL, and then we go ahead and apply our filter. So I want only MPG and cylinder, and I want that for only cases that have 4 cylinders. And we see that our output in the console demonstrates we got just that. We have MPG and cylinder, the only value that shows up for cylinder is 4. So those are a few quick ways to work with what you already have. Generally filtering to rows that you want and selecting only the columns that you want. And we can use the piping operator to make our programming a bit easier to read and a little bit cleaner to keep track of. Now, how would we create something new in the TidyVerse? Well, there's a function called mutate. So let's take data.00 and we'll use our piping operator again, and we'll mutate our data frame. Now we all know what mutate means. It's going to change. It's going to look different. So how is it going to look different? It's going to have a new variable. So let's say we want to calculate, I don't know, how about miles per gallon per cylinder? Well, that new variable, miles per gallon per cylinder, will be equal to MPG divided by cylinder. We execute that, we'll go down in the console and look at our data frame. You can see that our data frame looks exactly the same in terms of the variables we have, except we have one new one, MPG per sil. So we successfully created something new in our data frame, and this new variable contains the ratio of MPG to cylinder. In the first row, you can see that MPG was 21, cylinder was 6, and so the ratio of 21 to 6 is about 3.5, which shows up in MPG per cylinder. Okay, so we have our mutate function then. Well, maybe we want to summarize this data frame. Now that we know what MPG per sil is, maybe we want to know, well, what's the average MPG per sil by group of cylinder? Okay, so we can then group by function sil. So it'll take our data frame and group all of the observations according to how many cylinders that observation has. So for example, it'll group all of the 4-cylinder cars together and all of the 6-cylinder cars and all of the 8-cylinder cars together. And then once we have the grouping done, we want to summarize. Use the summarize function. And we want to say that mean MPG per sil is equal to mean of MPG per sil. And we'll go ahead and execute that. Now what will happen whenever we execute this is the summarize function will collapse our data frame so that each value for cylinder only gets one record, because we grouped the data by cylinder and asked to summarize each of those groupings. When we execute that, we see we only get 3 observations down in the console. 4 cylinders have an average or a mean MPG per sil of 6.67. The 6 cylinders are 3.29, and 8 cylinders have an average of 1.89. And this makes sense. The more cylinders you have, the bigger engine you have, the less fuel efficient your car is. Very good. So we can filter to rows that we want. We can select columns we want. We know how to work the piping operator. We know how to create new variables and summarize by groups. That's enough basics in R to get us going. There is one more thing we'll need to do, and that's how to create a basic plot. So let's just go ahead and execute the plot function. And we'll say the x-axis is going to be data.00 in cylinder. We'll just plot cylinder. Data.00 in MPG on the y-axis. And then we'll say, oh, maybe the x label is cylinders. The y label is miles per gallon. And we'll color this red, and we'll give it a title of maybe miles per gallon by number of cylinders. And we'll go ahead and execute that. And you see over here now in our plots window, we get a nice plot. We can zoom that in. We have a plot titled MPG by number of cylinders, and we see that our graph then shows cylinders on the x-axis. We only have data for 4, 6, and 8, which corresponds to our data frame. And on the y-axis, we have miles per gallon. And so again, we see the group of 4 has relatively higher miles per gallon. The group of cars with 6 cylinders is kind of in the middle. And the group of cars with 8 cylinders has the lowest grouping for miles per gallon. All right, there you have it. Some basic orientation to the RStudio window, the pane layout, and then some TidyVerse standards and some basic TidyVerse data wrangling management, as well as a simple plot. These are all the foundational tools you'll need for our programming as we proceed through the course and get into some of the machine learning coming up next.